Hi folks, decided it was a good day to take another board out of the pile and see what I could do with it. This one is a Rastan board, which I bought in 2000, and I labeled it in 2002 as having no sound. And I don't remember if it ever had sound when I got it or not. So let's plug it in and see if we get any sound, and then assuming we don't, see what we can do about it. Okay, let's power it up. And we do have Rastan coming up on the monitor, so that's a good start. But if I coin up, yep, no sound. So fortunately the game itself seems to be working, but no sound. So let's start with the obvious, which would be the volume control is turned down. And nope. I get a little more background noise if I turn it all the way in one direction. And the fact that I get a little buzzing sound when I touch it means that the audio amp itself is actually working. So we probably don't have a problem, at least as far as the audio amp to the output. But now we need to figure out if we're not getting any sounds generated or if the sounds are not getting to the amp. So the schematics have many pages. Fortunately, the sound part of it really comes down to 2 pages. And the first one has the Z80 CPU, the ROM, the RAM, and an interface chip. Unfortunately, it's a custom chip that goes between the main processor bus and this Z80 that does the sound management. So that effectively right there is the separate computer that runs the sound section. And it plugs into a Yamaha FM synthesis chip, which plugs into a DAC, which plugs into some analog op amps for the output. And that takes care of the music and some of the sound effects. And then there's also what they call a voice section, which plays pre-recorded samples. And that is done with some counters, a fairly large EEPROM, and a mux that flips between the bottom and the top 4 bits of the 8 bits from the EEPROM and sends them to a specialized DAC that takes the 4-bit input and converts it to a 12-bit output, which and then actually the actual analog conversion part is only 10-bit, so it's getting 10-bit samples off of this EEPROM, even though there's only 4 bits being passed to it at a time. And that also goes to some op amps to filter out some noise. And then the FM synthesis from the other page and the voice from the top of this page are combined into this op amp amplifier section. And then there's the volume control and the main audio amp out. So at this point, we are pretty sure that everything from the volume control on is all right, so we don't have a bad capacitor here or anything. Because if I turn up the volume control, I get more background noise, and if I touch the contacts on it, I get buzzing. So audio amp circuit seems to be good. So now, the fact that we're not getting any sound, either the music or the voice effects, means for an analog problem, about the only thing left is this op amp here, the one that mixes all of the outputs. Because if any of the earlier ones are bad, we would get at least one of those types of sound, but we aren't. So either we have a problem with this op amp, or the sounds are not being told to be generated, which I suspect is more likely. I suspect that for some reason it's not actually telling the sound chips to make sound. But let's stick with the analog for now, since that's pretty simple to take a look at. So probably the easiest way to do that would be to just plug in, tap into this with the scope and see if there's anything showing up on it. Okay, got the scope turned on, and what I'm going to do is I'm going to measure what's going on at these capacitors here, C18, 19, and 20. See if there's any sound coming out of those. And let's see if we get anything on these. Not looking good. I'm going to have to conclude that these sound chips are not being told to produce any sound. So let's see what's going on with the Z80 CPU. We got a clock, and let's make sure reset is not active. Reset is high, so that's good. There is activity on the address bus, so the Z80 CPU is at least functioning. One other thing to check is the self-test mode, which, according to the manual, if I flip switch 3 on, well, that's not so good. In test mode, nothing comes up. Just every few seconds it makes a little flash of static on the screen. So I don't know if that's a watchdog telling it to reset and it's trying again or what, but self-test doesn't run. Let's see if we can figure out if the main CPU is actually trying to communicate with the sound CPU. Now on this custom chip, there's basically 4 bits that pass through, and there's one address line, so I'm not sure if that means it can pass multiple chunks of data at the same time. This chip's not documented to my knowledge, so I don't know exactly how it works. But it looks like you've got clocks going in on each side for the master and the slave, because they're running at different speeds. It looks like the 68000 runs at 8 megahertz and the Z80 runs at 4 megahertz. And there's read and write lines, and there's the 4 data bits and an NMI, non-maskable interrupt, which I'm assuming that means when there's data being sent from the main CPU, it's going to trigger that NMI, which forces the CPU to listen to it. So let's see if that NMI signal is actually being toggled. So it should be that when it's sending a command to play a sound or to turn on or off the music, it should be that NMI line toggles. So that's pin 12 on the custom. Okay. I actually think it's working because I'm coining up. Yeah. It is toggling periodically, and you can't see the screen, but it's actually kind of in sync with what's going on, so it's trying to play the sound effects. So that's actually mildly encouraging, because we're getting as far as from the main CPU to the other side of the custom chip. Now that doesn't mean that there's something else, that nothing else is broken on this custom chip, but it's at least encouraging that the NMI is doing something. Let's see if this Z80 is trying to read this guy at all. Well, I decided it was looking increasingly more like a communication problem between the main CPU and the sound CPU. So I decided to hook up the logic analyzer to the interface chip that goes between them. And as often happens, some interesting things turned up. The top 4 lines here are the I/O bus on the main CPU, and the next 4 lines are the data bus on the sound CPU. And so this is effectively the input from the main CPU and the output to the sound CPU. And it can actually go in both directions, but primarily it's going to be the main CPU telling the sound CPU to do something. And down here are the control signals that manage the reading and writing. And I triggered on the interrupt pin, so that's when it's telling the sound CPU there's something there. And what I found that's interesting is one of the bits of these first four, these are the I/O bus on the main CPU, one of them doesn't seem to change. If I measure it with the logic probe, it is pulsing a little bit with the sound events as they're happening. So the line basically toggles between floating and low. And the other lines don't do that. So I suspect it's a problem, and I'm going to look in the schematics for the main CPU to try to figure out where that signal comes from. Well, I found where the I/O bus originates. It's coming from a 74LS245 chip here, and that's a bidirectional buffer, which basically means it repeats and strengthens signals so you can connect more devices to something. So if a CPU can only connect to a limited number of devices, the signals aren't strong enough, you can put one of these on there and you can connect additional devices to it without loading it down. And it's also switchable, so it can be enabled and disabled as needed. And in this case, it's acting as a bridge between the main CPU bus, the main CPU data bus, which connects directly to the CPU, and the I/O bus, which connects to some things like the dip switches, the player controls, and the sound system that we were looking at. Now, when we were looking at the data bus on the logic analyzer at the custom chip, there was a data line that was always low, and that seemed suspicious. It didn't seem like that should be the case. And since that's coming from this 245 here, I could just go ahead and replace this chip, but I think I will connect the logic analyzer first and see if the inputs and the outputs match, which would mean that the problem is not this chip, that it's originating somewhere else. Okay, well, the buffer chip seems to be okay. The top four lines are coming from the master data bus from the main CPU, and the next four lines are what are coming out of that 245 IC. It's sending high, 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 and it is putting out a high, 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 high. So the chip itself seems to be working, and I wasn't seeing any high when I measured it at the custom interface chip that goes between the two CPUs. So I think there might be a broken connection between this chip and the interface chip that connects the two CPUs. So I'm going to investigate that. Well, I confirmed with my meter that there is indeed a bad connection between that buffer IC and the interconnect IC. So I've been looking around on the board a bit for damage, and I'd noticed a couple of things before, but none of them looked too serious. There's a little tiny scratch right here, but I'm pretty sure those are okay. On the back, we have this one, which again seems, well, this one seems to be kind of on the surface. So I think that's okay as well. I may try to do a continuity check on some of those lines just to make sure. But there's one more that looks worse than I would have thought, and that is this one here, which looked kind of like the surface one at first, but you can actually kind of see the separation in the copper. So I'm going to check that with a continuity test and see if there's any lines there that need to be repaired. That may not solve the connection, the interface IC connection problem that I have, but if there's bad connections here, they've got to get fixed too. So let me measure those out and see what we need to do. Well, I've definitely got bad traces here, so I'm going to have to patch those up. This is under a counter IC for the voice output, so I suspect this will not fix the connection between the main CPU and the sound CPU. I may just have to run a patch wire for that directly rather than figuring out where the original break is. But let's solder some wires on here and see where we get. And here's the repair. It's 3 small wires and a small piece of resistor lead for one of the traces that I had enough room around it to just put a patch right there. And I tested the line between the 2 CPUs that was broken before, and it appears to be working now. So I am going to plug this in and see what happens. Let's fire it up. Well, I heard kind of a click that I didn't hear before. Let's see. Let's see what happens. Hey, there we go. All right. And we've got sound. Let's try the self-test. See if that works now. Yes. Well, this turned out to be a relatively simple problem, but it's a good reminder that, again, check for physical damage. If something looks suspect, check it. Check it again. Definitely before you start replacing components, it's a good idea to check for the simple things first. Anyway, as always, I hope this was interesting, and thanks for watching. And I decided for the heck of it, I'd pop it in the Double Dragon cabinet and actually give it a whirl. And it's reminded me that this monitor really needs a cap kit. It's bent on the top and kind of bouncing around a little bit now. So looks like I may have gained another project.